Hello, and thank you for the invitation to give this presentation on living evidence, bringing guidelines to life. It's a pleasure to be involved in your international conference on EBM. Now, 10 years is a long time in the world of evidence synthesis. Back in 2014, the concept of living evidence was barely on anyone's lips, and now, certainly from where I sit in Australia, it has become commonplace. One example of this is from March this year, when the Royal Australian College of GPs issued a press release calling on our federal government to invest in living guidelines so that patient care and health outcomes can be informed by the latest evidence. This is a message that is being repeated across the health sector in Australia. It is gratifying to know that the two organisations I'm speaking on behalf of today have played an important role in getting us to this point. But before I begin, I should say something about me and my role. So I've been with Cochrane for nearly 30 years, and for the last 15 years I've been co-director of Cochrane Australia at Monash University in Melbourne. We receive funding from the Australian National Health and Medical Research Council to coordinate and promote the work of Cochrane in Australia. I'm also the information specialist with the Australian Living Evidence Collaboration, or ALEC, of which more later, and ALEC was established in 2018 to support and develop living evidence and living guidelines. It too is based at Monash University and is funded by several state governments, societies and philanthropic foundations. So my presentation will follow the journey of living evidence from concept to reality, consider the drivers behind living evidence, include reflections on our experiences to date, and offer some insights into the opportunities and challenges that lie ahead. Along the way, I'll draw on my involvement in several living guidelines, including for stroke, COVID, and pregnancy and postnatal care. So let's start way back. Football fans in the room will instantly recognise this as Diego Maradona, captain of Argentina, holding aloft the World Cup trophy in Mexico City after defeating West Germany, which gives you a clue as to how long ago this was. The year was 1986. At that time, a younger and energetic former obstetrician in Oxford, Sir Ian Chalmers, was busy preparing the groundwork for what would become the Cochrane collaboration in 1993. In 1986, Ian published a letter in The Lancet in which he wrote, "Next year, the Oxford database of perinatal trials will be published by Oxford University Press in electronic form. The database will include a library of trial overviews which will be updated when new data become available." The Oxford database of perinatal trials was the precursor to the Cochrane Library, and the rest, as they say, is history. So here, almost 40 years on, we can trace the origins of living evidence. And this was a core founding principle of Cochrane. Author teams who embarked on a Cochrane review were expected to maintain their review by incorporating new trials. An arbitrary interval of 2 years was set, though we must acknowledge that throughout Cochrane's history this has been a significant challenge. Living evidence then, as a concept, might seem new, but like the French expression "plus ça change, plus c'est la même chose" implies, the more things change, the more they stay the same. So what do we mean by living evidence? Put simply, living evidence focuses on ensuring that evidence products such as systematic reviews, clinical practice guidelines and other evidence syntheses are continually updated to ensure they always reflect the entire body of evidence. It's not hard to see why living evidence is an attractive concept. Patients, carers, clinicians and policymakers all want the latest and most reliable evidence to inform their decisions. However, it's only in the last 10 years that living evidence has become part of the language of research synthesis. Prompted in part by an influential paper on living systematic reviews from Julian Elliott, a colleague at Cochrane Australia, and others in 2014, which defined living systematic reviews. In an analysis of nearly 800 trials incorporated into 70 systematic reviews in the field of neurotrauma, seen here on the right, the median time from the publication of a primary study to its inclusion in a systematic review ranged from 2.5 to 6.5 years. An earlier study by Shojiania from 2007 provided early empirical evidence of the problems facing evidence synthesis. In a cohort of 100 systematic reviews, the median duration of being free of a signal for updating was around 5 years. Or, to put it another way, by 2 years post-publication, around a quarter of systematic reviews that have not been updated will have failed to incorporate new evidence that will substantively change conclusions about the effectiveness or harms of therapies. So the challenge of review currency can be summed up by recognizing that there is a burgeoning volume of primary evidence. Reviews take a long time to produce, can be out of date on publication, and are difficult to keep up to date. Furthermore, as this diagram shows, the time taken to create and synthesize evidence may seem quite speedy compared with the time taken to implement that evidence in practice. This may still be typical of many research areas. The key challenge back then was to break the evidence trade-off. Reviews were either current, but perhaps lacking in rigour, or rigorous, but not up to date. The problems with systematic reviews are largely mirrored with guidelines. In Australia, NHMRC has a long history of developing guidelines and supporting others to do so. It published its first standards in 1999, which set out the requirements needed to obtain NHMRC approval. And in 2011, it endorsed the grade and approach to assessing the certainty of evidence. Following a series of roundtables with guideline producers, NHMRC released a consultation paper in 2016 titled Better Informed Healthcare Through Better Clinical Guidelines, in which several challenges facing clinical guidelines in Australia were outlined. Among the challenges cited were poor quality, so recommendations were not informed by the body of the best available evidence and processes that are not transparent. Lack of capacity, so expertise in systematic reviews and guideline methodology. Lack of investment in information technology, so a dependence on manual systems and static publication formats. And obsolescence, keeping up with research and keeping recommendations up to date. This last challenge, keeping recommendations up to date, is a particular problem for guidelines, given the sometimes lengthy time required to produce them and the multi-year interval between updates. Most guideline handbooks recommend that guidelines are updated every 2 to 3 years. However, it is widely acknowledged that achieving these timeframes is a significant challenge. Hence the obsolescence of many guideline recommendations. The first steps towards realising the promise of living evidence began with guidelines and systematic reviews in the areas of stroke and traumatic brain injury in the 2010s. At around this time in 2017, there was a series on living systematic reviews in the Journal of Clinical Epidemiology. The fourth paper focused on guidelines. In the paper, Arkell et al. Define a living guideline as an optimization of the guideline development process to allow updating of individual recommendations as soon as new evidence becomes available. Well-conducted systematic reviews, continually up to date with new emerging evidence, raise the possibility of timely, reliable guidance serving as the basis for living guidelines. In the conventional and still predominant model of updating recommendations, the entire guideline is updated at set intervals, every, for example, 3 to 5 years following its publication. The limitation with this approach is that individual recommendations, represented here by the horizontal blue lines, have varying survival times since the underlying evidence, often in the form of systematic reviews, becomes out of date as new studies are published. Eliakal et al. Also point to a second limitation with the all-of-guideline update approach, which impacts on the efficiency of the updating process. Update too frequently, represented here by the vertical red line, and for recommendations in which the evidence base is stable and unlikely to change, the effort involved in updating, searching, screening, appraising, is potentially wasted. But update too infrequently, and potentially most of the recommendations will be out of date. The authors thus make a distinction between individual recommendations and the whole guideline, with the former, i.e. individual recommendations, being the principal unit of update. So this slide compares the standard model of guideline development with the living model. A guideline has high reliability when it's published, but as the pink dotted line shows, reliability diminishes over time as new high-quality evidence becomes available. This could be in the form of a major primary study or an updated systematic review. By the time the 3-year update is planned and underway, the evidence is no longer current. With living guidelines, we are trying to smooth out the peaks and troughs by updating frequently so that recommendations maintain a high degree of currency. As new high-quality evidence becomes available, there is a continual process of development and updating, seen here as the blue loops. Ideally, the high resource requirements and intensive efforts involved in producing standard guidelines are replaced with lower but more even resource requirements that are spread out over the life of a living guideline. So an example of the traditional standard guideline model is the last static edition of the Australian stroke guidelines that were published in 2017, 7 years after the previous version. It meant that new evidence published in 2010 or 2011 wouldn't be reflected in the guideline until 6 or 7 years later. An analysis of the guidelines showed that the median time to incorporation of new evidence was nearly 1,500 days or 4 years. And I'll come back to this example later. It was envisaged that living systematic reviews would be the major pillar of living guidelines, producing the regularly updated evidence base that is needed for their success and sustainability. Hence, the circumstances for adopting a living guidelines approach share many similarities with living systematic reviews. The criteria proposed by Elliott et al. Back in 2014 for living systematic reviews have been widely adopted for living guidelines. So is the question or recommendation a high priority for decision making? Is there uncertainty in the existing evidence that is liable to change? And 3, is there an expectation of new research becoming available? The extent to which a living model is applied and the approach adopted depends on several factors. Chief among them might be the resources and personnel available to maintain a guideline in living mode. We have identified 4 approaches to help guideline producers consider what's right for them. The first approach is to develop a traditional guideline from scratch or adapt an existing guideline and maintain all recommendations in living mode. The Australian stroke guidelines are an example of this. In the second approach, rather than maintain all recommendations, the guideline panel or experts select specific recommendations to maintain, and this is similar to what we're doing with the pregnancy and postnatal care guidelines, of which more later. And third is to identify key priority topics that meet criteria for a living approach, so the high priority, uncertainty and new evidence expected, develop baseline recommendations, and then maintain them. And this is the approach that's been adopted for the Australian diabetes guidelines. And finally, you might develop criteria, such as the publication of a major new study that impacts an existing recommendation, and decide to incorporate that evidence. And the Australian COVID guidelines are an example of this approach. I just want to return to the example of the stroke guidelines for a moment. These are comprehensive guidelines covering acute care, rehabilitation, long-term recovery and secondary prevention. The first two guideline updates in 2007 and 2010 followed a 3-year cycle. And by the time of the third update, this interval had blown out to 7 years, requiring evidence searches to be rerun within the update period. Over 109,000 abstracts were screened for all 89 topic areas, dozens of search strategies across multiple databases. The guideline team at the Stroke Foundation declared, understandably, that this was not sustainable. The expert clinician panels, the evidence team and methodologists were all exhausted by the process. In 2018, the guidelines transitioned to living mode. It was decided at the outset that the entire guideline would be living, not just specific sections or recommendations. Now, as the guideline information specialist, this made my life easier. I created a single PubMed search to identify randomized controlled trials and systematic reviews relevant to stroke, which runs monthly. Using Covidence, an online systematic review management tool, the evidence team triages relevant records to the guideline chapter and then a specific topic, at which point members of the guideline panels assess whether the study warrants further consideration and incorporation into the existing evidence profile. So about 450 records are retrieved each month, which in the hands of an experienced team takes about a day to screen and triage, vastly more efficient than the conventional model. Going back to this graphic, we can now see what impact a living model has had. At least 6 updates were published in the first 4 years of living mode, dramatically reducing the time taken for new evidence to be incorporated. During this time, there were 16 new and 19 updated recommendations. The key benefit of living guidelines is the ability to rapidly update recommendations in response to new evidence. As a case example, results from a multi-centre randomised trial demonstrating the safety and efficacy of thrombolysis up to 9 hours after stroke were published in May 2019 in the New England Journal of Medicine, followed soon after by a systematic review and individual patient data meta-analysis. By November 2019, the updated recommendation had completed the full development, review and public consultation process and was endorsed by the NHMRC and disseminated to key end-user organisations, a total time of less than 6 months. A key enabler of a living approach is the technology, tools and platforms that are now available. MagicApp is an authoring and publication platform that allows authors to write and publish their guidelines in a highly structured fashion using the GRADE methodology. As individual recommendations are updated, the guideline can be republished, an essential requirement for living guidelines. As this flow diagram from the stroke guidelines shows, structured data also facilitates more targeted dissemination and implementation of recommendations in divisions, decision support systems, and electronic medical records. Alongside MagicApp is Covidence, which we use across all our living guidelines and reviews. Covidence now incorporates the Cochrane RCT machine learning classifier, built on training data from several 100,000 manual screening decisions. The RCT classifier automatically excludes records that are highly unlikely to be reports of randomized trials. When screening records where RCT is an inclusion criteria, using the classifier can reduce the screening load by 20 to 30%. The stroke guidelines were the first national living guideline in the world. 6 years in, we can confidently say they are feasible to produce and acceptable to both developers and users. Some early Google Analytics demonstrated a marked jump in use of the guideline tied to the dissemination and communication activities that coincide with each major and minor update. No one wants to expend a lot of time, effort and resources to produce high-quality, reliable guidelines if they're not going to be used. Thus, it's essential that development and implementation go hand in hand when planning guidelines. Implementation, like updating, shouldn't be seen as an afterthought. One of the reservations raised by several Australian guideline developers we interviewed in 2016 was the potential for recommendations to continually flip-flop in a living model, creating confusion among practitioners and decision-making. The fear being that more frequent evidence surveillance would result in more frequent changes to recommendations. However, both the stroke and COVID guidelines have shown this to be very rare. For example, only one of 35 new or updated recommendations in the stroke guidelines has changed direction, from a weak recommendation for to a weak recommendation against. Typically, new evidence either confirms the existing recommendation, both direction and strength of evidence, or leads to an upgraded strength of evidence. This was the case with the COVID guidelines that were updated weekly during the first 12 months of the pandemic. This slide shows the accumulation of recommendations for different drug treatments for COVID over the first 15 months of the guidelines. Invariably, the first study of a new treatment leads to an only in research recommendation because the evidence is too uncertain and imprecise. Over time, as more studies are published, the evidence leads either to a use or do not use recommendation, but doesn't flip from one to the other. We can see this with the example of convalescent plasma. Early studies were small, resulting in very low certainty evidence, and a use only in research recommendation. As the evidence accumulated, seen here in the yellow section, the certainty shifted from very low to low, but still not sufficient evidence to change the only in research recommendation. It was only with the publication of the large recovery trial that we could recommend with high certainty not to use convalescent plasma. Both the stroke and COVID guidelines are part of the Australian Living Evidence Collaboration, or ALEC, a national network of guideline producers that provides practical support but also advances methods for living guidelines. All these guidelines are published via the Magic app and can be accessed via our website livingevidence.org.au. Also to flag that we published an open access series on methods for living guidelines in J-Clin-Epi at the beginning of last year, and each paper provides practical guidance on different aspects of the living guidelines model. In this brief journey through living guidelines, I've tried to emphasise some of the key enablers that contribute to the feasibility and success of living guidelines, including technology enablers like Covidence and Magic App, and the integration of dissemination implementation in the living approach. Finally, I want to emphasise that the evidence review work doesn't take place in a vacuum, but sits within an organisational and governance structure that ensures the guidelines are not only reliable, but are best positioned to impact practice and decision making, and I regard this as the third key enabler. The structure of the pregnancy and postnatal care guidelines is typical of our approach. So once the evidence is prepared by the internal evidence review team, the draft recs go to the panels for further review. These panels are made up of multidisciplinary clinicians and researchers from around Australia. Panel recommendations then go to the National Guidelines Leadership Group, GLG, which reviews all new and revised recommendations. The GLG also prioritises new topics for evidence review and provides advice to the steering committee on emerging clinical and research issues that are relevant to the guidelines. Recommendations reviewed by the Guideline Leadership Group require 100% consensus endorsement from the LEAP steering committee before being submitted for public consultation and NHMRC approval. The steering committee is made up of over 20 member organisations involved in the guidelines. These include colleges, professional societies, and consumer groups. Although the process of securing 100% consensus can involve a lot of back and forth on the exact wording of recommendations, it does mean that everyone, colleges, clinicians, consumer groups, is equally invested in the process and has equal ownership of the recommendations. I think this is a crucial aspect of implementation, as these groups are the most effective conduits for disseminating evidence to their members. Consumers or patient groups are involved in all aspects of development of the LEAP guidelines and are represented on the steering committee, guideline leadership group, as well as the two guideline panels. They contribute to online discussions and meetings and provide strategic consumer input into the guideline development program. Earlier I showed this slide of the evidence ecosystem as it was, with the delays of many years baked into the system. What I hope I've been able to convince you of today is that with a living evidence model, combining technology with co-production partnerships and robust synthesis methods leads to evidence being available for implementation within a matter of months, and even quicker in the case of COVID. So let me wrap up by offering a few reflections on opportunities and challenges that are likely to impact on living evidence. The world of automation and artificial intelligence is moving rapidly, and barely a week goes by without a new evaluation of the application of large language models to various steps in evidence synthesis, from abstract screening to risk of bias assessments and data extraction. Cochrane, like many other evidence synthesis groups, is aware of the significant opportunities AI could bring in enhancing the quality and efficiency of health evidence synthesis, but it also shares the concerns within the health research community about how and when AI can be integrated safely in a way that doesn't undermine trust in its evidence outputs. Cochrane currently has a draft policy out for community consultation on recommendations for responsible AI use in evidence synthesis. As a search information specialist, I'm especially interested in the potential of new mega repositories such as OpenAlex, a vast collection of scientific literature 7 times bigger than PubMed, and research is currently investigating if OpenAlex as a single source search platform could replace the traditional approach of conducting searches across multiple databases. However, AI and automation are not without their pitfalls. There is potentially a double-edged sword to these innovations. Not only do we have easier access to the rapidly increasing global scientific output with fewer geographical and linguistic biases, but we also have easier access to potentially thousands of problematic, fraudulent and fabricated studies. Predatory journals and paper mills, the organisations that produce and sell fabricated papers, are now a permanent feature of the academic publishing landscape. As such, research integrity and how to detect problematic studies is a hot topic in evidence synthesis. The indiscriminate inclusion of such studies has the potential to undermine the reliability of systematic reviews and guidelines. Living evidence syntheses are particularly vulnerable in this scenario. So we are at a curious historical juncture where research evidence has never been more abundant or quicker to access. What the eventual implications are for producers of evidence synthesis are still mostly unknown because the very latest tools and technologies are not yet mainstream. The second trend to note is initiatives to promote better global collaboration in producing evidence. In the past, this has proved a major challenge. The Australian Stroke Foundation, for example, has for many years tried to collaborate with its counterparts in Europe and the US to share the development of guidelines, but with limited success. The Alliance for Living Evidence, or ALIVE, aims to act as a broker between different groups involved in creating living evidence by formalising agreements and standardising processes. As an example of this, the ALEC diabetes guidelines include recommendations for drug treatments for type 2 diabetes. We now have an agreement with groups in China and Norway to share the screening of monthly searches, extract data using commonly agreed outcomes, conduct predictive bias assessments, and synthesise the data. Resulting from this are several outputs, including a jointly produced network meta-analysis of over 850 randomised trials. The same data will then be considered by each respective guideline group to develop recommendations that are locally relevant, accounting for drug availability and costs, etc. So to conclude, I hope I've demonstrated that compared with non-living approaches, which are often onerous to produce and become rapidly out of date, living evidence syntheses provide decision makers with highly reliable and, where appropriate, contextualised summaries of evidence as evidence emerges in near real time. Living evidence has become feasible with methodological and technological advances in the past 5 to 10 years and has been embraced globally, with the WHO, Cochrane, Pan American Health Organization the United States government, and the National Institute for Health and Care Excellence all committed to adopting living evidence approaches. And that's where I'll leave it, and thank you very much for listening.